Welcome to the Fourier transform lecture series. In this video I will discuss another example. In this way you can able to understand how you can determine the Fourier transform having the differentiation process. So if you are asked to determine the Fourier transform like this signal, then in this process you need to differentiate the signal into times. So as we can see here, this is a ramp signal having negative slope. So after differentiating that portion, we will get a unity step having this fashion like that. So another ramp is here. So this portion will be replaced after differentiating that part. This is another ramp having positive slope. So this unity step could be presented here for the differentiation of xt for this portion. Another ramp is here who is having the slope is negative. So this portion can be presented as like that. So actually this signal can be represented for the differentiation of the xt which has already given there. So the ultimate in first step our ultimate goal is to determine the 2 times derivation. This is the first time derivation of that signal, and if we want to determine this 2 times derivation, again we have to differentiate that signal. So we know that after differentiation of unity step we will get the impulse function. So in this portion actually downwards, so we will get at this portion the downwards impulse. This in that portion, for this portion we will, after differentiating, we will get the upward impulse in upward direction. However, this portion will also generate a impulse for the upward direction. So after summing up at the 2 impulse at same point, our magnitude will be doubled. Actually you can if you place your closed loop, this magnitude is 1, this magnitude is 1. For this section you will get a impulse having a positive 1 magnitude, also in this case a positive 1 magnitude, and after summing up 2 you will get an impulse at that point having the magnitude 2. So in the similar fashion this signal actually been achieved after differentiating this signal. So our first stage was the 2 times derivation of a given signal. We already have been performed. In my previous video I discussed this process. You can also determine the signal in a function. You can transform, and after differentiating that function you can determine the 2 times derivation of the given signal. So basically this signal actually can be represented in this fashion, as I have discussed in previous videos, that how can we represent a signal in different singular function. So this is the ramp. Also the slope of this ramp is 2 times, so 2rt plus 1 and t minus 2 and t minus 1. So basically after seeing this equation, this function, you will not able to directly understand how to determine that, but as I have said in class and in this video, that how to determine this signal using the different singular function. So I hope you can understand that, and I think that you are able to write this function from after having the signal xt. So if you have the xt like that, you need to differentiate 2 times. So after differentiating 2 times, you basically will get the signal like that. So basically this is the this function actually represent the signal of this signal. Actually these two are same, so you can go any fashion, any way. So in the first step you basically you need to have the 2 times derivation of given signal. So after that what should we do? We need to perform the x omega. Actually basically we need to transform this signal into we need to transform the Fourier transform actually. So we know if we transform this signal, just we place j omega with the order how many order or how many degree that we had in the derivation part. So this j omega square and the Fourier transform of xt is x omega, so this is suitable for that. And after transforming del t as like e to the power j omega, as we have discussed already in previous videos. So after transforming into Fourier transform, then we need to determine the x omegas. This is the x omega, and this is the ultimate goal to determine the Fourier transform of xt. So basically in this way you need to determine the x omega of a given signal xt. In the first stage you must need to differentiate it 2 times, and after having that you need to transform, and at the final stage you need to determine the x omega. I think the key point or key factor would be the differentiation. It is very basic and very easier, and the important thing is to practice how to transform the Fourier transform of del or impulse function. Okay, I hope it would be very easier for you to transform in this fashion. Already I have discussed in Fourier transform properties, or in previous video you can check. Thanks for watching. Welcome to the lecture video of Fourier transform. In this video I will discuss about another example by which we can determine the Fourier transform of a given signal xt in the 2 times derivation as we have discussed in previous videos. So in this video actually this is the signal that we need to transform into Fourier transform. So basically here this portion is basically the ramp. This is the unit step, this is the another ramp. So we need in the first step basically we need to have the Fourier transform, we need to have the derivative 2 times. So in this if this is given xt, so we need to perform the first derivative. So after having this portion would be transformed like that, having the magnitude would be actually the slope of this portion. Magnitude of this portion is here, this magnitude of this portion is like that. So the slope would be the magnitude a divided by tp minus tq, and after derivating that signal, this signal will be achieved, and finally this derivative of that signal would be that. In that case we know that the differentiation of the unit step would be two impulse would be achieved. At that portion there will have a upwards direction impulse, at that point there will have a impulse in the lower direction. So basically after 2 times derivation of differentiation of that signal, this signal will be achieved. So this was the basic how could we represent the ramp signal or a signal in terms of different singular function. So in this similar fashion actually we can go through this way. exploring this signal into this fashion, these functions, and the ultimate goal is to determine the second order differentiation. And after that we need to perform the Fourier transform of that signal. And the most important thing is here we need to know the Fourier transform of impulse function. In the previous two lecture, actually I tried to mention that it is very urgent to know the Fourier transform of del function. So to solve this way, this is the key point or key term you need to know. So in this fashion, when as you know that for the Fourier transform of differentiation, you just need to put the j omega with the order of differentiation. Here is second order differentiation, so j omega would be placed second order, and the Fourier transform of xt is given by x omega. So the Fourier transform of that part is like that, and the Fourier transform of each impulse function is like that, and are like that. And at the end of this transformation we need to determine the x omega, and the x omega would be like that. So there is two basic steps. We need to differentiate two times of a given signal, and after transforming that you would need to determine the frequency domain of the given signal. I hope it would be very helpful for you, but the ultimate the important thing I want to mention is that you need to practice more for having a smooth performance.